morning all again. Okay, let's start our next topic. So our next topic is breach trust. Okay, using ILD. So we are going to discuss about that. So next, our next topic, our next unit is breach trust. Okay, what is the effect of load in trust? Okay, so here as you can see, this is a truss, and which part is what it is showing here. So all of you please go through this. There is a truss is given. So as you can see, these joints, all the joints here like this, these joints are called pin joint. Okay, all the trusses are connected by pin joint. The above chord is called top chord, bottom chord is called bottom chord, and the in between this diagonal, these are called diagonal chord or wave. Okay, these are also wave or vertical chord. So in every chord or every member, it may be compression or tension as per the load applied or loading occurs in particular truss. Okay. So what is truss basically? A truss is a triangular structure consists of three member normally. All are connected by pin joint. It is the most stable form of structure which is economical and carry maximum load. I think all of you know this thing. These are the basic things. So the loads are applied on the joints only. Okay, remember this. The loads are applied in the joint here. As you can see, there are some joints in truss. Okay, so it is showing here in the video. There is two reaction R1, R2. This is simple for your understanding. I have shown you. So if we consider a simple truss like this, how many joints are there? You can easily say by counting 1, 2, 3, 4, 5, 6, 7, 8. Okay, here you can see total join is 8. This, and how many members are there? Again, if you count the members, you can easily say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. There are 13 members. Okay, these are the basic things. So in every members, the load will be applied, okay, through the joint. Okay, it may be compression or it may be tension. I think all of you know when we call it is compression, when we call it is tension. Okay, if a load is applied outward direction, then we can easily say that the load is tensile, and if it is applied in the inward direction, we can easily say that that type of load is compressive or compression load. Okay, and this is the basic things. So here you see, just for your understanding, if you consider this a truss, if we name the structure as here, assuming we are assuming a load here P, this P, we are assuming a load in L naught E1. If we consider this as L naught E1, we are considering a load is applied P1. Okay, so if we assume P L naught E1 as positive and the direction is correct, then we can easily say that this load is tension as it is going outside. Okay, if the direction is wrong, if the direction is got negative, then we can say that that will be a compressive load. Okay, when we solve numerical, as per that we need to consider the loads. If we solve any numerical, if we got the values, if we need to first, what we need to do, we need to assume the direction of the load. Okay, and after calculating, if we got the positive value, then we can say that our assumed direction is right. Okay, or if we get the opposite value, then we can say that our assumed direction is wrong, the load is applied in the opposite direction. Okay, here you can see, while analyzing a truss, initially we have to assume the direction of the member forces, either tensile or compression, because without solving any member or any structure, we can't say that where the load is tensile or compression. Okay, so for that, what we need to do, we need to consider, we need to assume the load as tensile or compression. Okay, so there are some method. So first method is our method of joints. So in this method, what is there? Free body diagram are used for joints along with the equilibrium equation. As all of you know, what is our equilibrium equation? We have already discussed. There are three equilibrium equation. This basic three equilibrium equation, all of you know, summation of P, summation of H, and summation of F must be 0. So when this method is used, method of joints, this method is used only when the number of unknowns are equal to 2 or less than 2. If there is 2 unknown value or less than 2, then we can use this method of joints, or else we need to go for another method. We will discuss that method in other method in the next part. So as you can see, if we consider a simple truss, 3-member truss, we are considering a 3-member truss here. This 3-member truss, L1, L2, and L3. Okay, so here you see, if we take out one portion at a time, if we consider this L0, this part, if we consider this part, so what are the loads is applied here? You see from the below, the reaction R1, in the right side a member is going up through L2 and one is going to L3. Similarly, if we take this, you will get one structure like this. Okay, so now what we need to do, we need to solve these things. Okay, so there are how many unknowns? There are, if we find out the reaction, there is only two unknowns, this L2 and L3. So we can use this method of joint. Okay, because reaction we can easily find out if we know the length and all these things. Okay, this is one method. Okay, next is our is method of section. This is our method of section. Okay, if we are considering a truss like this, what we need to do, we need to cut the section in a particular point. Here we are considering one this line, we are cutting this portion into two portion. Here you see, we are considering that point into two parts. So by this, how we need to solve, how we need to find out, let's try to solve one numerical. Okay, here you see, we are considering a truss. This truss, as you can see, this truss we are considering all the loading, all the length, and all these things are going. We are numbering the truss as 1, 2, 3, 4, 5, 6. So what we need to do, we need to calculate the member forces. In every member, what is the forces will come. Okay, it's very simple. Just you see, first what we need to do, first in the first step, assign the joints and members. We need to assign the name, some name. Okay, as you can see here, joints we are numbering at as 1, 2, 3, 4, 5, 6. There are 5, 6 joints, 1, 2, 3, 4, 5, and 6. Okay, so we are numbering that joints. After that, we need to number the member. Okay, you can number it as your convenient way. As you can see, I am numbering here as member 1, 2. See this member 1, 2, then 2, 3, like that. All this naming are done. Okay, so after that, what we need to do, we need to number the forces, member of forces. Simply just put P in front of these things, these values. Okay, these values P1, 2, P2, 3, P1, 4, P4, 5, P5, 6, P5, 3, 6, like that, so on. Okay, these things you number it. This is our first step. First step is our, we need to number all the members and all the joints. Okay, what we need to do next, we need to do the, in step 2, calculation of reactions. We need to find out this reaction. As you can see, there are reactions here. This is a fixed point, so we will get one reaction from here. R4y, here R6y. Why? It is in the direction of y direction. That's why. Okay. So see this reaction R4x, R4y, R6y. From this here also one reaction will come as it is a fixed joint. This is R4x. Okay. So by using the horizontal forces, you can easily say R4x is nothing but this is given in the same direction. 20 kilonewton load will come. Just put all the values. You can easily find out by using this equilibrium equation of the reaction. Okay. Just try to do this by horizontal, taking the horizontal forces. In here, only horizontal forces 20 kilonewton is there. So only that will come. So similarly, if you consider the vertical forces, here only one load is given, this 70. So that will come R4x plus R6y equal to 70. Similarly, if you consider the moment about any point, by considering that, you can easily find out one value. From that, you just put here, you can also find out that R6y. Okay, this thing I think all of you can easily do. So next, what we need to do, we need to find out the calculation of member forces. Okay, so for that, we need to consider a joint one by one. So we are considering this joint, number fourth joint first. We are going from this way. So considering the fourth joint, whether the loads are coming, you need to draw that. Okay, you need to draw that whether the members are connected and whether the loads is given. This is the value we have already find out. That's why we directly put that value R4y. This 25. This is already given. And consider the direction as per your convenience. Okay, if the above side it is in the outside, below you also consider that direction. Okay, same way this direction. So by again you need to follow the horizontal, vertical, all this equation. From that, other the unknowns you need to find out. I think these things is very simple. You can easily find out. So we need to repeat this in all the joints. In the next for joint one also, again we need to repeat the same things. I think all of you know how to resolve the forces. If the angle is given along the angle, it is cos theta, and against the angle, it is always sin theta. So you can easily calculate these things also. Just put the values, try to solve all these unknowns. These unknowns we need to find out. And remember one thing, whatever you have calculated in the earlier join, if the values you can use in the next join, you can directly use that value. Okay. So all of you go through this one by one. Similarly, all join for join two also you need to find out. Just consider the members which is connected in that joint. Okay, you need to consider all the connected members connected in that particular joint. If you consider the joint 2, as you can see here, there are 4 members connected in that joint. Here you see this joint 4. One is coming from the above, 2 from the right and left, and one is going to below. There are 4 members is connected in that joint. So as you can see here, there are 4 members. So again, by solving the horizontal vertical way, just resolve the force. Similarly, go through the point zone 5. All the steps are all well explained here. Just go through one by one step and try to do by your own. Okay, just don't read from here. Just try to solve it by your own. Keep this as your reference and try to do all the for all the joints. Okay. So all of you please try this. Okay. Let's let me show you some next thing. Are we all able to see this? Is this PDF is okay? So this is see what is the objective of this lesson. The main objective is understand the bridge transport flow system and load transfer mechanism. Draw the influence line for the truss reaction. Draw the influence lines for the truss member forces. Okay, after finding out all those things, we can easily draw these things. So here you see what we discussed in the previous part. In the previous part, we have studied the development of influence line for beams loaded with single point UTL and series of load. In similar fashion, one can construct the influence line for the process. The moving loads are never carried directly on the main girder but are transmitted across cross girder to the joints to bottom cord. As you can see, there are so many cords are connected in a truss, so it is always moved through the girder to the bottom cord. Okay, so here we are going to discuss about how the loads are transmitted. As I have already said, you to resolve the forces in all the joints. If you do that, you can easily say at which member what is the load is coming out from the given loading. Okay, so the numerical which we have discussed already, all of you try to do that by following the steps. Okay, try to find out all the load in all the member. Okay, after finding out that, you can easily say that how much load is coming in which member. So here you see a typical bridge floor is shown in this figure. Here it is showing. Don't worry, I will share this PDF with you. So this is a structure is given, this truss, all the naming, how they have done, L0, L1, L2, L3, L4, L5, L6. These are the bottom and the upper code. That's why you they have marked as U1, U2, U3, U4, and U5. Okay, upper and lower. That's why U and L they have used. Okay, here you see this is the floor plan. These are the stringers. These lines in between. This is the front view. Okay, and this is the plan diagram. If we draw, and always remember, it should be noted that for any load position, the truss is always loaded at the joint. As I have already said to you that the all the loading is applied to the joint and it is transmitted through the members to the bottom core. Okay. So here you see, this is the influence line for truss support reaction. How we need to go. There is a truss is given. This length all is given. Everything is given. So at A and B, we need to find out the reaction of all these things. Okay. There are some steps how we need to solve. I will give you this PDF also. All of you please go through this PDF. There is a numerical. Construct the influence line for the force line member GB of the bridge truss shown in figure. This figure. So how we need to solve. All the steps are given in step by step. So if you go through this numerical, you can easily understand how we need to find out. There are some examples. All of you please go through this. Okay. Because this is a little bit long numerical, and if you follow that step, you can easily find out. So all of you please try to solve this. Okay, I will share this PDF with you. Go through this PDF. Very simple things, as we already did the post resolution and all these things. Just a little bit adding with that, because there are so many members and all these things. So we need to find out for all the members by considering all the joints by one. Very simple thing. You can easily understand, or you can easily calculate this. Okay. Okay. Is there anyone want to ask anything? Anyone have any doubt if you want to ask, you can ask. Okay, Masuma, you were saying that you were disconnected. I was not able to understand the last part. And which one? That PDF, handwritten PDF part? Okay, fine. This one, this numerical. Okay. For this numerical, what you need to do first, I am repeating one by one. First, what we need to do, we need to number all the join and all the member and all the member forces. Okay. Our first step is we need to number, because if without numbering we can't solve this, because it will be complicated or it will be mixed up. So after numbering, what we need to do, we need to find out the reaction which is coming in that particular joint. So in our case, there will be three reaction will come out here. In this point 4, there will be two this, and in the 6 number point joint 6, one reaction will come, as it is a roller structure. As you can know, for roller and for fixed, you already know which kind of reaction will come. So as per that, you need to find out the reaction. Okay. So after that, what we need to do, we need to consider one by one joint. As here you have seen for joint 4, we are starting from this joint. So first we consider the joint 4. Then we need to draw this free body diagram, which are the loads and which are the members connected through that. So after that, if all the members are unknown, I think in our case there are two or three, two knowns and two unknowns. So just put the knowns value, and by using the equilibrium equation, find the unknown values. Okay. By that way, what you need to do, you need to consider all the joints. There are 6 joints, so you need to do for all the joints and all the members. By considering all the joints, just try to do. And remember, this 45 angle is given. Always remember, in a crutch, if there is something given in between the diagonal chord, it is always in a 45-degree angle. Okay. So that's why we are directly using that 45-degree. And by force resolution, as you can know, as you know, along the direction it is cos, and against the direction it is sine. By using that cos sine also, if you resolve the force by using the equilibrium equation, just simply you need to use the equilibrium equation, and you need to find out all the unknown values, all the unknown members, or which are the force coming out in all the members. Just simple that. So you try to do one by one. Similarly here we are considering joint 2, joint 5. After finding out all the members, just stop there. Okay. Just you need to find out what are the forces coming out in each member. Okay. Is it clear now? Just try to solve this. Okay. Without solving, you will not able to understand. First, you need to solve. Try to do it. Okay. Is there anyone have any doubt? Till then, all of you please give your attendance in the chat box also. Is there anyone left to give you attendance? Okay, then everyone, all of you please go through the all the notes and all these things. I am giving you the PDF. I will share in your class group, and all of you go through that and try to do this numerical by your own. If there is any confusion, all of you please come up with that in the next class. Okay. Till then, thank you all. See you soon.